construction when I first started my career, and I did my master's and PhD in civil engineering and then became a professor. And so I've spent many, many years looking at pavement performance, asset management, helping cities determine how to invest their funds to get the most out of their infrastructure. So I'm going to talk a little bit about that, and I'm going to share some of the key concepts related to infrastructure management. And then I'm going to speak very briefly about a project that we've been working on related to emissions associated with vehicles and how those emissions differ depending on the pavement structure. And then I'll close off with some conclusions. So one of the areas that I think we really need to think about when we think about our infrastructure, so this is our roads, this is our buildings, this is our bridges, this is our sewers, this is all of the infrastructure that supports our cities and airports. And the idea here is that we put a monetary value on the assets because it emphasizes their substantial value to us. So if you live within a high-functioning road or a high-functioning airport, then your quality of life is going to be much better. You're going to have access to goods and services that you wouldn't normally have. And so the idea here is that we figure out how old the infrastructure is, what the value is, and really what I'm going to be talking to you about is the importance of investing in maintenance and rehabilitation. So we can't just build the infrastructure and not do anything with it. We have to continue to think about how we monitor it. So I'm really going to emphasize the value of transportation assets. I'm going to talk a little bit about present, current, predicted, and desired asset condition and how we figure out what the asset is worth. Identify funding needed, so how much money do we need to spend every year to maintain that infrastructure so it keeps its value? And then what are the financial risks if you don't do that? What happens if you don't actually continue to invest? What's going to happen? So this is actually the Federal Highway Administration in the United States initially published it. It was further published in the Transportation Association of Canada Pavement Asset Design and Management Guide, which is the primary document in Canada that we use to design all of our infrastructure. And basically the idea here is when we think about infrastructure management, we have different system components. So what are our goals and policies, and how does that reflect the customer input? Who are our customers? If I'm the DOT or I'm the city, who are our customers? Everyone that lives there, right? The users. And so what we need to think about is what is our mission as an organization? What are the goals and policies? We need to know what kind of assets we have, how many roads do we have, how many bridges, how many sidewalks, how many freeway traffic management signs, how many ramps, how many bridges, all of these pieces. And when we think about the inventory is what kind of inventory of assets do we have, what's included. Then we get into things like what's the value of the asset and what's the function, what services do they provide. So if I switch to an airport application, what is the most important asset at an airport? Somebody tell me, what do you think? Air traffic control, but what is air traffic control managing? The planes and the runway, right? The runway is the most important asset because if the runway is shut down, everything we get congestion in the terminal because nobody can move, and there's actually a traffic management problem in the sky because the planes can't land. So this is what we start to look at is what are the value of the assets, what are the functions, what services do they provide, and we look at it from a systems approach, right? Like we have all these interconnected pieces of infrastructure, and what are the really important pieces that connect them? We think about things like condition. What's the past condition? What's the performance into the future? How do we actually predict the performance? And then we do some modeling. And we come up with different alternatives to figure out how to repair them or how to keep them in good shape. And this is where the discussion today is going to go. The JP has this technology actually improve the infrastructure, but also do it in an environmentally friendly way. So the idea here is that we have a bunch of tools in the toolbox, and we have to figure out how to efficiently use those different alternatives. Of course, part of this is we have budgets and allocations, and we don't have unlimited budgets. I have worked with agencies around the world. I have never been to a place where people say to me, Susan, I have unlimited budget. We always have a limited budget, so how do we use those? Short and long-term plans, how do we implement the program, and then performance monitoring. So the one thing I would say is the technologies that we're using now are very high tech. We're using artificial intelligence to manage our infrastructure. We're using machine learning to actually help us design better. So there is quite an important technical component that's helping us learn how to better manage this infrastructure. Okay, so this is probably my most favorite slide. I've taught many, many years, and what I want, and this was part of the Transportation Association of Canada, and this is really talking about the life cycle of the asset. So when we come in and we think about infrastructure, we think about the entire life cycle, the planning and programming, and what's in the shaded area, the type of data that we use. So we use all of this data to help us figure out the planning and programming. And then we move into design. So we start to look at these nanomaterials or high-performing materials or recycled materials and the environment and the design alternatives and sustainability. User costs we think about. So if we have to shut that highway down and we have all our users having to drive around and take alternative paths, or there's a lot of delays, that costs us, right? That costs us, those trucks are stuck in traffic and they can't deliver their loads. So we think about those things. Then, of course, we construct it, and there's data. Then we get into maintenance, preservation, rehabilitation. So this is, how do we keep it in a good condition? I'm going to come back to this. In-service evaluation. So this is where we're using a lot of high-speed technologies that drive down the road and look at the cracks and figure out where the potholes are and actually help us say, oh, this is the performance of the surface now, and in 1 year's time, we're going to need to do something. So we use these photos, we use lasers, we use high-speed cameras to actually figure out how it's performing. And then at the end of the life, what we're trying to do is recycle and reuse materials. So we want to really look at how we can, those materials don't end up in a landfill, that they actually are reincorporated as long as they're good. So that's the zero waste management. So we take all of this information and we feed it into a database. And this database helps us drive our decision making. It helps us determine what we should be doing and why we should be doing it and how we should be approaching it. The other research loop is really about, are the design methods, are the maintenance methods working? How, when we say, so as a civil engineer, I go into a situation and say, I am designing this bridge to last 20 years. And I'm coming back to say, did it last 20 years or did it only last 15? Or did it last 25? Or if I recycled materials, did it actually perform the way I thought it would? So one of the case studies that we've done recently for the Ministry of Transportation has been to look at vehicle fuel consumption and emissions and what significant impact they have on human health. So we know that if you live close to a facility that has a lot of traffic and a lot of emissions, and I thought this was a good example for California because I know this is a major issue in California. There's many examples I could have shared, and I'm happy to offline talk to you about some of the others, but we know there's traffic-related air pollutants, we know there's environmental damage costs. So this study that we just completed was looking at how the condition of the road affects the emissions, so what's going into the air. And we're looking at the pavement-vehicle interaction and also the excess of fuel consumption. So what we actually have been calculating here is what we call the environmental damage cost of air pollutants. And so what you can see on the left side of the graph here is a flow chart where we actually have calculated the damage from atmospheric releases. So my colleague who actually did her PhD at MIT, she's an air quality specialist, and she's been working with me on the harder side on the infrastructure. And looking at the policy or design, so for our colleagues who are in government, what are the policies and what kinds of baselines do we expect? How that actually impacts our ambient conditions, our population demographics, because obviously depending on your population, emissions could have an even higher impact on the population. What kind of health impacts would you have, and then the valuation. And here on the right are values that we were able to develop, and they look at, so these are Canadian dollars per milligram, and you can see the different types of emissions and what kind of cost is associated with those for the province of Ontario. So what am I really talking about here? Well, basically what I'm talking about is the rolling resistance can lead to excess fuel consumption and emissions. So the rougher the road, the more fuel it uses. The more fuel it uses, the more emissions you're going to have. So, and the types of things that we look at optimizing, so I know there's lots of entrepreneurs in the room, so how do we optimize the texture of the pavement? So texture is very important because of course it contributes to roughness, but most importantly, texture is important for friction. So friction is what helps us stop that car or stop that airplane quickly, right? And so we need to supply friction on our surface, but in a way that it doesn't make it really rough. The roughness is sort of the component where you're driving along and you actually feel it, right? Depending on your suspension of your vehicle, but you feel it. And then deflection is the structural adequacy of the actual infrastructure that you drive on. Okay, so very quickly, one of the things we did related to this is we wanted to look at energy use and emission impact models. So basically what you see in the top part of this figure is you've got roughness and texture, vehicle efficiency, and speed and congestion. So we actually used one of the models from the World Bank, which is the Highway Development and Management tool, and looked at energy use rate. So how much energy are we using based on different scenarios per carbon dioxide. The other portion here is a program by the U.S. Federal Highway Administration, which looks at motor vehicle emission simulation, and it ultimately also gives you energy use and emissions. And then we actually plug that into a model where we look at running different scenarios for different roadways and figuring out what kind of emissions are coming, the emission impact model, and also the energy use. So here's some actual results. Unfortunately, I left them in kilometers per hour. So I think 70 kilometers is about 40 miles per hour, something like that. And 100 kilometers is about 62. But the point here is what we have based on actual data from the province of Ontario. We have a percentage change in energy consumption as a function of IRI. IRI is roughness. IRI is this International Roughness Index, which is the pavement vehicle human interaction. And it actually is calibrated, it's calculated very sophisticatedly. So 1 is a smooth pavement, brand new pavement. 4 is a very rough pavement. And so what I want to highlight here is that higher speeds and rougher roads result in more energy consumption. So us as users, as drivers, we pay for that. All of those goods and services that are being transported, we pay for that because it costs more for trucks to cart materials and goods and services. Okay, now this is also, so in the more specific thing, we're looking at carbon dioxide emissions related to what I'm calling roughness management. So if we have better control over the smoothness of our road, and we have smoother roads, then what we see here is that we have a lot of savings. So we can see the y-axis here is percent of carbon dioxide emissions as a function of kilogram per kilometer. And this is what I want to highlight here. So if we don't have any action, if we just leave the road and keep it and not really look at sustainable techniques, that's what we're going to get. We're going to get excess CO2 emission. If we start to look at some different kinds of treatments, like green treatments, like the hot-in-place recycling, like sustainable techniques, which we actually looked at here, you can see there's savings. There's savings because the road is smoother, those green. There's potential savings because we don't have this emission cost. And then we also have some savings related to maintenance and rehabilitation. Here is the environmental cost savings as well. You can see again, if we use different techniques, we actually have a bigger impact on the roadway network. So I'm just going to conclude that based on studies that we've looked at for different kinds of roads, rougher pavement surfaces results in a 2% increase in fuel consumption. For heavy-duty trucks, it's a 3% increase. Now, you might not think that's a lot, but when you apply this across, think about all the trucks in this country that are hauling goods and services. It's billions of dollars. So that is a big impact. And it's also, generating more emissions. The second piece is when we look at rougher pavement surfaces, the environmental damage cost, it works out to be about 4 cents per mile for cars and about 2 cents per mile for heavy-duty trucks related to emissions. So again, these are additional costs. And so I think the challenge is, how do we reduce those costs? How do we make things more efficient? If we have lower values for how rough we can allow our infrastructure to get, we'll have more emissions. And what we do know is if we are recycling or using more sustainable materials, we actually have huge benefits, and particularly on high volume roads. So when you start to get into the interstate freeways, it really starts to add up. And then of course, another big part of this is decreasing the CO2 emissions. So some of the work that we've done, and we've said to our DOT partners, is if we can reduce that, it's going to have a huge impact over the life cycle. So again, I hope what I'm leaving with you is this idea that the road surface has a huge impact on the vehicle emissions. It has a huge impact on the environmental costs. And the more traffic we have and the higher volume facilities, and I haven't shared airport information, but if you have, our major airports like San Francisco, where you've got the Kodak new generation aircrafts, the A380s, the Boeing 777s, like these costs really start to add up. We need to ensure our infrastructure is sustainable, safe, and cost effective. And so I actually strongly believe that we can use sustainable materials and designs and management practices that are cost effective and also quite beneficial. And the other thing is, one of the challenges that we've had in a lot of construction is we have traditionally always gone with the lowest cost. Low bidder wins, right? So low bid wins, but low bid is not always the best choice. And in fact, often it's not the best choice, because if you pay a little bit more and use some better materials, you actually get a longer life. Why do people buy a Tesla, or why do people buy certain cars that they buy? Because they're not always going to buy the lowest cost. And yet, a lot of our public infrastructure is built based on lowest cost. So, I just want to leave you with an idea. Years ago, I spent my first academic sabbatical working in Australia for one of the largest contractors. And the thing that really stuck with me then, and it's really impacted everything I've done up to this point, is they had these P3 projects they were responsible. They were building tunnels through Sydney and bridges in Melbourne. And I remember showing up for work one day, and it was pouring rain. And my boss said, we're going to send all the crew home. And I was really surprised at that, because they were there to work. And he said, well, we're responsible for this road for 30 years. And so we know if it's raining, and we know if the conditions aren't great, we're not going to get that design life out of it. And so I think that this is an opportunity in the highway field, in airport and transportation, to really think about how we actually commission infrastructure and how we actually manage it. So with that, I thank you, and I think they're giving me the hook. And I think we'll do questions after. So thank you.